Hello, so we're going to combine our techniques on finding critical points and our techniques on finding inflection points to create a summary behavior. So simply put, we're going to have to create a rise and fall pattern and a concavity chart, and then combine those charts onto a single chart. So let's first create a rise and fall pattern. In order to do that, let's take the first derivative and identify any possible critical points. So we have the first derivative is 4x to the third minus 6x. Let's set that equal to 0 to find critical points. 4x to the third minus 6x equals 0. 2x times 2x squared minus 3 equals 0. X equals 0 is one critical point. 2x squared equals 3, x squared equals 3 over 2, so x equals radical 3 over radical 2. Make sure that's a positive negative, which means x equals positive negative radical 6 over 2. So these are our critical points. So now we don't know if they're a max or a min. If we wanted to determine if they were a max and a min, we could take the second derivative and plug in these points. A rise and fall pattern is not reasonable justification for a max or a min. So if I wanted to determine if x equals 0 was a max or a min or neither, I would take the second derivative and plug in x equals 0. So let's create a rise and fall pattern. I have all of my critical points listed in order. And now I'm going to use these factors of my derivative to determine the sign of the derivative. So I had 2x was a factor, 2x squared minus 3 is a factor. Multiply those things together for the sign of f prime. So I'm going to plug in negative 3. Negative 3 times 2 is a negative number. Negative 3 squared is 9. 9 times 2 is 18. 18 minus 3 is a positive number. And a negative times a positive is a negative. Decreasing. Let's plug in negative 1. Negative 1 squared. Sorry, negative 1 times 2. Negative. Negative 1 squared is positive 2. 2 minus 3, sorry, negative 1 squared is 1 times 2 is 2. 2 minus 3 is negative, and a negative times a negative is a positive. So the function's increasing there because the first derivative is positive. Let's plug in positive 1. Plug in 1, get a positive number there. You plug in 1, you get a negative there. And a positive times a negative is a negative, therefore the function is decreasing there. And let's plug in any number greater than radical 6 over 2. For example, 5. 5 times 2 is a positive number. 5 squared times 2 minus 3 is also a positive number. And a positive times a positive is a positive. Therefore, the function is increasing there. So there is our rise and fall pattern. Now let's create a concavity chart. Our first derivative was 4x to the third minus 6x. Let's take our second derivative to find any possible critical points. So f double prime of x, 12x squared minus 6. So let's set that equal to 0 and solve for x. Positive negative radical 1 over radical 2. So you get x equals positive negative radical 2 over 2 as your possible inflection points. Again, it's possible because we have to show that concavity changes across these points in order for it to be an inflection point. So we're going to do the same thing we did with our first derivative, and except now we're going to do it with our second derivative to determine the concavity chart. So we really only had one factor of our second derivative, and that one factor was 12x squared minus 6 equals 0. I could make this a little easier to work with, and I could say that this is 2x squared minus 1 equals 0, just to make it easier to evaluate. So there's the factor of our second derivative, and we're going to plug in intervals which satisfy, we're going to plug in numbers which satisfy these intervals. So let's plug in negative 3. Negative 3 squared is positive 9. 9 times 2 is 18. 18 minus 1 is a positive number. Therefore, concave up. Positive people smile. Let's plug in 0. You get a negative number. Negative people frown. Concave down. Let's plug in 2. 2 squared is 4. 4 times 2 is 8. Gives you a positive second derivative, therefore concave up. So we can assume that negative radical 2 over 2 and positive radical 2 over 2 are both inflection points because the concavity changes there. So now what we're going to do, we're going to combine all of our information that we have here, our rise and fall pattern, and our concavity chart onto one chart. So I'm going to list all of my values in order. Negative radical 6 over 2, negative radical 2 over 2, 0, positive radical 2 over 2, and radical 6 over 2. And what we're going to do is put all of our rise and fall patterns onto this chart with its corresponding concavity. So now, according to our rise and fall pattern, we were decreasing until we got to negative radical 6 over 2. Decreasing. We were increasing until we got to 0. Well, here's 0. So we're going to be increasing on both of these intervals. Increasing, increasing. Let's go back to our rise and fall pattern. We were decreasing until we got to radical 6 over 2. Decreasing, decreasing. And then we were increasing after radical 6 over 2. Increasing after radical 6 over 2. Now we'll input our concavity directly below that. We were concave up until we got to negative radical 2 over 2. So we're concave up until we get to radical 2 over 2. Concave up, concave up. After negative radical 2 over 2, we were concave down until we get to positive radical 2 over 2. So from negative radical 2 over 2 to positive radical 2 over 2, we're concave down. And then according to our concavity chart, we're concave up thereafter. So concave up, concave up. So now what you have to do is think of the concavity as the way you're bending the line. So this line is going to be bent down, creating a concave up. This line from the middle will be bent down, creating a concave up. This line here will be bent up, creating a concave down. This line here will be bent upwards, creating a concave down. This line here will be bent downwards, creating a concave up. So think of the concavity as the way that you're bending your rise and fall. So my pieces of my graph will look like this, and I'm just trying to create a little puzzle here. It's going to look like that. Decreasing, concave up. Increasing, concave up. Increasing, concave down. So bend this up. And each one of my previous pieces should fit with the next piece. So this one here will look like that. bend it up. This one, bend it down, like that. And this one, bend it down, like that. So now I have all of my pieces to create my general shape of my graph. So the general shape of my graph, if I take all these pieces and connect them together, will look like that.